Architectural Builder Supply is pleased to present you with this recording of the technical question that is listed in the title of this video.
This call may be monitored and recorded for quality assurance.
It was on an interior door, and I want to use it on an exterior door. I looking through the varying options from Rixson. Why would I want to use? Why would I use a 117 versus a 147 versus a 117 and a half potentially, other than weight? Is that the only determinant in your opinion?
It is not the only determinant. The difference in those pivots is not only their weight capacity, the size and the height of the door, the width and the height, but also how they mount. You've got different mounting types that are there. I believe they're all offset, but two of them I think mount to the floor, but one of them doesn't. So where do you want to attach the bottom portion?
Yeah, I see that the 117 quarter is mounted to the jamb. The regular 117 and the 147 and the 117 half are all floor mounted, which is what I would like. Yeah, I guess I can just figure this out myself. I just haven't used any of those hinges. I've only used the interior, the 128 one time. The offsets for how it closes. I'm in Montana, so I need to obviously think about wind and cold versus what seems like a lot of people do. So how it shuts against a sealed stop is important, and therefore I think the offset is what I need, and I just need to figure it out in my model, how it swings and the swing it needs, for clearance. So I'm not sure where to go from here. Actually, I can purchase from you, correct?
Yes.
Okay. I guess I'll figure this out and then let you know.
Well, what is it that you need to figure out? Meaning, you've got me on the phone. Let's do it together.
That's what I expected or wanted. So some of these pivot doors,
the 117 and the 147 is that's going to be a weight situation only between those two. You also said 117 and a half. The weight.
What situation?
The difference between the 147 and the 117 is a weight situation. WEIGHT.
Yeah, I see that. Yeah.
And in fact, the dash half is, so you've got small, medium. Well, you've got small, medium, and then medium plus with the 117 and a half. But that's a different animal when you get that 117 and a half, because the first two in order, 117, 147, 117 and a half. The first two, you mechanically attach those to the floor. You get to the 117 and a half and bigger pivots, you are no longer screwing that to the floor. You're pouring it in concrete. You're setting it in poured concrete.
Yeah. I'd love to see somebody pull that detail off, but that's not going to happen.
Happens all the time.
Okay, great. People are much better than I am then. I have a whole other detail I'm trying to figure out. So to me, it's how it closes against the stop, and so I just need to figure out from their drawing and put it into my model and see how that acts. But
you're also speaking about the difference between center hung and offset. When it comes to weather sealing a door, absolutely go offset every single time, because you don't have to be expert in any particular field to think about a center hung pivot and say, yeah, I'm not going to have really good weather stripping around my door. Unless, So unless there's a reason you're being pushed towards a center hung pivot, stick with offset, because it'll act just like a hinge in the sense of the way that it closes, the approach, the geometric approach of the door to the frame itself, standard weather stripping, standard door behavior, except it will be superior to hinges because the weight is borne on the ground naturally.
Yep. So what I am hearing is that it's a difference between the 117 and the 147, if I am understanding that correctly. Now, there's the LL147, which I'm not totally seeing the difference between the L and the regular, but clicking back and forth.
Two things. The weight, because the L is intended to carry a lead line door where the construction of the lead line door is through the center of the door, which is not how a lot of doors are built these days, but your lead line door can be. You're doing a residential project, I imagine. There's no X-ray machine. Yeah. You would avoid the L147. Unless, of course, you needed to hit that weight. How heavy is your door?
I don't know yet. I'm going to use an insulated core, and there's going to be a 16 gauge hot rolled steel on the outside face, and I'm not totally sure what I'm doing on the inside, but I'm going to be well within 600 pounds.
What size is the door?
So,
what size is the door going to be?
It's about 48 inches by 90 inches.
Yeah, you're going to be within the range weight-wise of the 147. Because if I looked up a 16 gauge hollow metal steel stiffened door, it's not going to exceed what a 147 will handle. If it's your house or if it was my house, I'd probably go with the 147. But then you have intermediate pivots as well that you'll need to pick up for that door.
Well, that was actually my bigger question now that you mention it. Why do I need intermediate pivots?
Because you would want a mechanical relationship between the door and the frame other than at the very top and bottom of the door. Especially a door with such disparate construction that you have, you would have no way to mitigate any sort of giddy up in the door, warp, bow, any sort of relationship where the door is not completely flat, measured corner to corner in relationship to the face at the top and bottom and through the edge. Weight-wise, you wouldn't need it, but they're just there to help keep the door straight to the frame.
Yeah. I understand, but so is that 165?
No,
the intermediate.
No, an intermediate for those would be like a 19, an M19 or an ML19. And the hot rolled is going to be on the outside, and the inside probably won't have hot rolled.
I don't think I'm going to do hot rolled on the inside, no.
So thermal bow is why you would have intermediate pivots.
Yeah. Intermediate pivot, there it is. So on those, the model M19, that's the one you would recommend.
Well, the door hardware industry would say for doors 7'6" and taller, you would use 2 intermediate hinges or pivots. What you end up doing is what you end up doing. You know what I mean? What I'm saying is what the textbook says.
Right. So is that what would you? I'm not right off seeing the difference between, or why I would choose the 119 versus the M19 or ML19, or how do I decide? How do I figure out which intermediate pivot I need?
So the 119 is simply more petite, and I've used that on doors that were shorter, but I still wanted an intermediate. So that might be a very nice option because it's not going to carry the weight. The M19 is the same version as the 119. It's just longer, taller. When you get into the ML, the L in this case stands for load bearing, so its construction will help carry the weight of the door. Which,
right. Yeah.
Once you determine your weight, and if you're grossly over-engineering what the bottom pivot can handle, I would go with standard pivots just to keep it straight versus load-bearing.
Yeah, I think as you've already inferred, I think I'm using this only to help keep the door aligned because of the warping on the outside with the steel. But I think the offset hinge, I'm well within the weight. So doesn't sound like I need the L. And then the 119 versus the M19 versus the M190, I guess it's a more visual thing, I suppose.
Yeah, size and what they're intended to carry in terms of weight, in terms of load.
Okay. All right. Well, let me figure out in my model to make sure let me go back to that. Where did I put that? On the offset, whichever one. Where'd that go? I accidentally
3/4 is what you'd want.
The 140. What did you say, Richard?
Offset. You'd want the 3/4 offset.
The 147.
Yeah, whatever pivot you use, do the 3/4 offset version of it. If it's available in 2 offsets, do the 3/4.
Okay, I'm not seeing description features. I'm not seeing the 3/4 part.
Are we looking at the
bigger? I'm looking at the 147.
Okay, so when I look at the 147, so you'll see in the technical drawing
3/4 offset. Yeah.
Yeah.
Sorry. Yep.
Yeah, face of the door to the center, the vertical center line.
Oh, I'm not looking at the drawing. I'm looking at the description features. The 3/4 meaning so the center pivot is 3/4 of an inch off of the center of the door. Center of pivot is 3/4 off the center of the door.
Actually, the definition of that offset would be the dimension from the face of the door to the center line of the vertical axis of pivoting.
Oh, so you don't place the arm centered in the door. I'd need to look at the drawing. Okay. And I can slide that in the width of the door. I can slide that to where I want it, to where it works best for my jam and clearing the stop, not hitting the stop, my seal, correct? Do you follow what I'm saying?
No to the former and yes to the latter. If you're going to deviate off the template in terms of the dimension from the rabbet to the vertical center line, you'll need to be quite mindful. You're going to want to put all that in AutoCAD and be quite mindful how that's going to require your relationship between the door and the stop to change. The face of the stop.
ArchiCAD. I'm glad I don't ever have to use AutoCAD. I use ArchiCAD.
Well,
but I'll put it in my model and figure out the swing. And you have the 147 in stock as well as the I guess maybe the 190, but it might be the M190.
Standard finishes. Those are kept in stock.
M19. So with hot rolled steel, I would want to go with a dark finish if you're calling that standard.
Antique brass, oil rub bronze, black, dark bronze, powder coated.
Black is what I would want to go with. All right, let me do some figuring in my model and get back to you on an order.
Cool. Thank you very much.
All right, thanks for your time. Appreciate your help.
Sure thing. Bye-bye.
Yep, goodbye. Hi. I want to go ahead and order that. I want to, before I finish my drawings, I want to get the hinge, but it obviously will work quite well. There's a few things in their template that don't look, that are a little unclear, so I wanted to just get the hinge. So could I order 147 offset with it sounded like the M190 is the appropriate intermediate pivot.
Definitely a good option for that. Yes, sir.
Now, whether two or one of those, I'm not totally sure. Again, my door's 90 inches. How much were those? Those were 18. Is that what I remember seeing?
The cost?
Yeah. Oh no, 18 is the 5x5 or 16, which I need to get also. Yeah, the cost on the intermediate, the M190.
M190s. And what finish did you want those in?
Oh, what do you call it again? The flat black, I
Right
think
on.
was one of the options. Yeah.
So those are $246 roughly.
The intermediate is?
Yes, sir.
Holy smokes. Just one then.
Right on. Okay. What hand is the door?
Left hand.
Okay. What will the rails and styles of the door, their composition, what will it be made of?
I haven't established that yet, but either solid wood or possibly tube steel.
Okay, so I'm going to tell the factory to go all wood screws and all machine screws. So it'll be in good shape.
Well, is that going to be a big difference, Richard, or is there going to be a cost there? Because I can get the screws myself, or I can just say.
No, not at all. No, there's no that's no impact on cost.
Okay. Yeah, I'm still trying to figure out the best way because, as you mentioned, the expansion and contraction difference from the inside to the outside, I might build this out of tube steel. The frame.
Yeah, right, exactly. Yes. I agree with that.
So, not to bother or trying not to bother your time, what I'm doing is I'm laser cutting the sill. I'm doing in 3/8 flat stock or 3/8 steel, and so I'm in ArchiCAD. I'm laying all these out so that when I send it to the laser, that they can locate those holes. Well, actually, sorry, to be more specific, what I'm doing is setting the foot plate down into the steel. So I'm having them laser out that 2 and 13 by 2 and 13 for the bottom. And then on the top, I then would locate and have them laser out the holes for the top pivot, for whatever that is worth.
Beats a die grinder.
What's that?
I said it beats a die grinder.
Oh, well, that and human error. I mean, I guess I trust the laser, the CNC machine, but that's what I'm going to attempt to do is lay it all out in ArchiCAD and then send it to the CNC machine, and then hopefully everything is good. So that was one of my reasons. When I lay it out based off of their template where the pivot point is, God, I'm horrible at reading these things, 3/4 off the face of the door and 13/16 off of the jamb, which gives, looks like an 1/8 inch gap. It obviously swings away from the stop nicely. But in the template drawing, that 2 13/16 doesn't line up with the furthest edge out of the base pivot, the pivot base. And I think it's just a drawing error, but there's something wrong on their drawing. I just want to get the hinge and make sure my drawing is correct before I send it to the CNC. Pardon all of that, but at any rate.
Okay. Do you want to talk about that template together?
Well, if you open that up from their website.
Yeah, I see the 2 13/16 dimension.
Okay. If you go over where it says 2 7/16, you go over a little bit more and you see the 3/8. That leader line doesn't line up with that bottom edge of the base plate or bottom pivot or whatever you call it. Do you see what I'm referring to? It's off by. So something's goofy there. Either this drawing is wrong or I'm wrong. But do you see how it doesn't line up?
Yeah, I do see what you're saying. So my interpretation is this: you've got 2 7/16 of an inch from the furthest portion of the floor plate back to the center line of the fastener that would be closest to the face of the door.
Right, but again, that 2 7/16 doesn't start in their drawing. I'm sorry, I'm being really pedantic here, but that
pedantic is my legal middle name, so bring it.
But that doesn't line up with that, and when I see discrepancies like that, my brain shuts down. So because then on the upper side in the drawing page up, where that 2 7/16, as you note that it is the center of that hole, but then they don't give, unless I do a whole bunch of math here, but from what I'm looking at, they then don't give what that dimension is. There's 2 parts to the bottom, right? And what I can't quite, or I'm not seeing in the drawing, those 2 parts need to be aligned at a certain, they key together, obviously being the center of the pivot, but I'm not getting another measurement showing where that happens. I didn't say that very well, my apologies.
Are you talking about the positioning of the arm itself in relationship to the face of the door?
The arm versus the base. When you put the whole thing together, that arm is, so I haven't three-dimensionally modeled this hinge yet because I don't know where the relationship of them, but and you're better than most people at following this stuff, and I've watched one of your videos, and I can see you obviously know what you're talking about. But if you start with that the arm being 1 3/16, right?
2 3/16.
The arm is 1 3/16 wide.
Oh yes, sir.
And 9 5/8 long. It's 2 1/4 at its widest point of the L, right?
Right.
Bottom left-hand corner. Yep. What I'm not very good at reading other people's drawings. Usually, I have to just draw it myself. Where that 1 3/16 width of the arm, I'm correct on that 1 3/16, aren't I?
Yes, sir.
The center of that arm versus the center of the mounting plate. I'm not finding a dimension how to figure out where. Go ahead.
So
sorry.
I would take on page 2, you've got 2 1/4 from the back of the arm to the center line.
Let me follow. Wait, Richard. Sorry. Let me catch up with you. I'm looking for there's so many damn dimensions. I'm looking for that 2 1/4. Just a sec. On page.
I'm
2,
looking at the
there.
147 template, which is called IS-147.
Okay. All right. So I'm on that. Okay. Just a sec. So 2 1/4. So 9 5/8.
To the left,
sorry,
and then below.
Okay. Yeah. Sorry. Got it. So that's from the outside, or mine's an in-swinging door, obviously, or not obviously, but so 2 1/4 from there to, that's the center of pivot, correct?
Yes, sir. I would take 2.25 minus parenthesis 1.1875 divided by 2 parenthesis, and then I would have the center of my arm to the center line.
Okay. You did that faster. Okay, so you're taking half the thickness of the door.
The 1 3/16, half the width of the arm. I would take half of that.
Okay, so
then I would,
half of the width of the arm.
Yes, sir. And I would simply deduct that from 2 1/4.
Oh, right. And that gives me, assuming what is that for, and I'm sorry, it probably says somewhere on all this, but what thickness of door is that for?
And that's the whole thing. That's the beauty of it. You can actually use that with any door thickness. However, when you leave the reservation and you go away from 1 3/4, the proper thing to do is to order the 147 for the thickness, because the 2 1/4 inch dimension now is going to change. It's going to increase. If you go to 2 inch, 2 1/4, 3 inch, 5 inch, whatever your door thickness, that arm for the bottom arm, and then the top pivot, all of that will change, because they really want the load. They want the arm centering under the load.
Right. So, Richard, this drawing is based on 1 3/4.
Most definitely.
Yeah.
You know, is there going to be a problem for 2 inch? Nah, not really. But if it was 3 inch, the factory says other than 1 3/4, you got to order it for the door thickness. So that's where your experience comes in.
And I'm assuming there's a lead time then.
Oh, most definitely.
Yeah. So I'm going to use some sort of insulation, rigid insulation, door core. They make door cores, as I'm sure you know. I was thinking of using probably a 1.5. The 16 gauge is obviously 16 gauge, and then on the inside, I can veneer cherry is probably what's going to be on the inside. I can veneer that. So yeah, I can be well within one. Well, certainly the thickest my door is going to be is probably 2 inches. And I don't want a lead time, so I think this will work fine. A stock 147.
Right on. I do agree with that, most certainly.
You concur. Okay, good. Okay. 147 set and an intermediate, an M190, just one of them in the flat black, please.
Okay. And let's take a look.
I have a question.
Sure.
When you have a moment. Okay. So, to digress for a moment. People claim that, or I hear stories that where people say I try to reinvent the wheel. I'm not, but people sure. I'm not going to use a threshold. I'm going to try and find some sort of good bottom sweep. But my steel threshold, again, I'm laser cutting all of this based off of my drawing, and my threshold is going to cantilever or go out and become an actual step, and it's just going to be all one piece of 3/8 inch steel. So it's this a threshold on steroids, so to speak.
Sure.
The beauty of a CNC, I'm probably wasting your time, so I apologize for that, but the beauty of a CNC is I can draw whatever and they will cut that. So for my jams, which is also 3/8 steel, I can do a quote mortise and tenon, so everything locks and will stay square before, so when I weld, it won't warp, at least at the attachment point. What am I getting at? Oh, so I'm getting at then is for my stop, and this is an in-swinging exterior door, my stops, I'm going to take 1 inch. I'm either going to key those in as well and have it laser cut from a sheet versus using an angle, like a 1x1 or 1.5 by 1.5. But that's ultimately what I'm shutting against is a steel stop. There's a reason I'm telling you this. I'm not sure at the moment what was so I'm not going to use a threshold, and I know that the real world isn't as perfect as my ArchiCAD model, but if I set that down, the bottom pivot plate, if I laser out that hole, so I have to either laser the screw holes or I have to laser the whole square. And the beauty of lasering the whole square is if you laser the holes for the screws, it hardens it and it makes it really difficult to tap. And so I'm going to opt for, just from experience, I'm going to opt and laser out that 2 13 by 2 13. So that'll drop that plate down. So the top face of it is coplanar with the finished threshold, finished floor. So that's going to drop the gap between the bottom of the door and that. Oh, that actually, it's saying 3/16, but that's. I'm just wondering what I'm not a 1/4 inch threshold, 7/8, 1/2 inch threshold, 5/8. Depending on how far. Well, I can adjust it by how far I put it, how deep I mortise that, like you were talking about in the 147 or the 128 video that you did.
That's right. So there is a direct relationship to the undercut that you need to accomplish and how deep the arm is. That's all there is. And a 1/4 to 7/8 and 1/2 to 5/8, that's a linear, obviously a linear relationship. So you can tweak that because you can see the formula.
Yep. Okay, I see now that they're giving us. Yeah, okay. Yeah, so all the more reason it would be just nice to have everything done before, have the hinge, verify my drawing, laser cut it, and then almost do the door after everything when I know. Okay, all right. Sorry for bothering your time on that. What will you attach the
bottom pivot to when you cut through your sill?
Yeah, good question. What I think I'm going to do, or my plan is on the bottom of the 3/8 plate. I was also, a part of my drawing would be a plate from the bottom side that I will attach and make a mortise, basically. Now, the plate of the of this 147, that bottom plate, I'm assuming, is a 1/4 inch.
3/16.
Thick. It's 3/16 thick. So that would locate it, but then I'd add a second piece of 3/16 in there, and that would all be a part of my laser cutting to have that. To answer your question more directly, I'm going to put a plate underneath before I set this whole jam thing.
Yeah. Are you going to have the top of the plate flush with your sill, or is it going to be 3/16 below the top?
Well, it's going to be flush, and
cool.
so I'm going to have to add another piece in there to raise it up
yes,
that
sir.
3/16. So it's not coplanar to the top, not the bottom.
Yeah, that's going to be awesome. That's going to, the question becomes, will you even need fasteners? Your bottom plate's not going to move. So, yeah, it's going to be great.
Yeah, that's do you think that bottom plate is weldable?
No, not at all. No, that's non-ferrous.
Okay, I wouldn't think so. Yeah, okay. I guess this is all the more reason I want it in my hand so I can kind of turn it, look at it and see how to attach that. I was wondering if a puddle weld from below, but yeah. I'm probably going to attach it to that plate and then puddle weld that. Just a tack weld on that plate from the bottom side. Not the Rixson portion, but my yeah.
Yeah. It's gonna be awesome.
Well, I hope. That's my intention.
Oh, it will be.
Thank you.
Yeah, no, I mean, it's okay. Maybe you have to recut something, but it's going to be beautiful, man. And I hope that you'll send me a photograph when you're all done.
I would gladly, and I appreciate having you as a source. I came across you somehow yesterday looking for the Rixson hinges, but I have a few other things I need as well when we get done with this part.
Okay, so I'll enter an order for a 147 in black left hand and a single M190 in black left hand, and I'll do that now. What is your email address?
Architectural Builders Supply hopes you have enjoyed this program.